Okay, think about your business for a second. You've got dozens, maybe hundreds of processes running all at once, right? Billing, manufacturing, customer service, the list goes on. But how do you actually know which ones are any good and how do you compare them? That is the billion-dollar question. And the answer is a powerful concept called process capability. So in this explainer, we're going to break it all down, consultant style, and turn that complex math into some real, actionable intelligence you can use.
All right, here's our game plan. First, we'll tackle the fundamental question we're trying to solve. Then, we'll draw a super important line between potential and actual performance. After that, we'll decode the metrics themselves, I'll show you a simple way to interpret them, and finally, we'll tie it all back to why this is an absolute cornerstone of operational excellence. So here's the classic challenge, right? Every leader faces this. You've got a process for shipping widgets and another one for answering support tickets. I mean, how on earth do you objectively say which one is better? You're comparing apples and oranges. Well, this is exactly the problem process capability was designed to solve. It gives us this universal mathematical language to describe how good any process is, no matter what it's doing. So let's start at the 30,000-foot view. When we talk about capability, what's the core question we're really trying to answer? It all boils down to one simple thing. Are we meeting our customers' requirements consistently? This is the key idea right here. You've got two voices. The voice of the customer sets the goalposts. These are your spec limits, the absolute minimum and maximum they will accept. Then you've got the voice of the process. That's what your process is actually delivering day in and day out with all its natural variation. Process capability, then, is just the measure of whether the voice of your process can fit comfortably inside the boundaries set by the voice of your customer. Simple as that. Okay, now for our first major deep dive. To really nail this, we have to be super precise about what we're measuring. And to do that, we're going to think like a consultant and use a MECE framework. That just means we need to cleanly separate our analysis into two buckets. Are we looking at the long-term potential of a stable process, or are we looking at the short-term performance of something new? So on the left, you've got CP and CPK. These fall under process capability. This is what you use for your mature processes, the ones that are humming along in a state of statistical control. On the right, you've got PP and PPK. These measure process performance, and they're for your new, maybe unstable processes, like a pilot run. For today, we're focusing on the big ones, CP and CPK, the metrics for long-term stability. And here's a little pro tip. The relationship between these numbers is an incredibly powerful diagnostic tool. If your process is truly stable and in control, your CPK and PPK values are going to be almost identical. But what if you see a huge gap between them? That, my friends, is a massive red flag. It's your data literally screaming at you that the process is unstable. You've got to fix that first. All right, so we've established the what and the when. Now, let's get into the nitty-gritty and decode the two most important metrics for our stable processes, CP and CPK. They sound similar, I know, but they tell you two totally different and equally critical stories. First up, we have CP, which stands for Process Capability Potential. CP asks one and only one question. Is the spread of my process narrow enough to theoretically fit inside my customer's spec limits? Notice it completely ignores whether you're actually centered on the target. Using the dartboard analogy, a high CP means all your darts are landing in a nice, tight little group. That's great consistency, but that group could be way up in the top left corner, nowhere near the bullseye. But let's be real, potential doesn't pay the bills, results do. And that's where CPK, the Process Capability Index, comes in. CPK measures reality. It looks at both the spread and how well that spread is centered. So to get a high CPK, you need that tight group of darts, and you need it planted squarely on the bullseye. It's the true measure of your ability to hit the target every single time. And this really says it all, doesn't it? That little K is everything. It's the centralizing factor. It's what forces the metric to account for where your process is actually aimed. Without the K, you're just dreaming about potential. With the K, you're measuring actual, on-target performance. And understanding these relationships is how you diagnose problems. First rule, CPK can never ever be larger than CP. If they're equal, perfect, your process is perfectly centered. But here's the most valuable insight. What if you have a high CP but a low CPK? That tells you something incredibly specific. It means your process is consistent. It's just consistently missing the target. The problem isn't variation, the problem is aim. You don't need to tighten the process, you need to recenter it. Okay, I know the formulas can feel a bit abstract, so let me share with you my absolute favorite way to make these numbers feel real. It's the garage analogy. And trust me, once you hear this, you'll get CPK intuitively forever. So, first off, just picture a garage. The walls of that garage, the left wall and the right wall, those are your customer's specification limits. The entire space between them is your window of opportunity. Go past those walls and you've crashed. You've made a defect. Next, your car. The width of your car represents your process variation. A big, wide SUV, that's a process with a lot of natural variation. A sleek, narrow sports car, that's a super consistent, low variation process. And obviously, it's a lot easier to park a narrow car than a wide one. So, what is CPK? CPK is the ultimate measure of your parking skill. It's not just about if the car can fit, it's about how much space you have on either side once you've actually parked it. CPK takes into account the width of the car, the width of the garage, and how well you centered it right in the middle. This table just makes it crystal clear. A negative CPK? Oh, that's a disaster. You've literally crashed the car outside the garage. A CPK of 1.0, you're just kissing the wall. There is zero room for error. But look down at the bottom. A CPK of 2.0, now you're talking. You've parked a tiny sports car perfectly in the middle of a two-car garage. You have tons of clearance. That is a world-class process. And the way it's calculated follows this analogy perfectly. The math looks at your distance to the right garage wall, then it looks at your distance to the left garage wall. Your final CPK value is simply the smaller of those two measurements. And why is that? Because you're only as good as your tightest clearance. It doesn't matter if you have 5 feet of space on your right if you're scraping the paint off on your left. CPK is your worst case scenario metric. All right, let's bring this all home. Why does mastering this stuff really matter? Well, this is the very heart of operational excellence. It's the foundation of the entire Six Sigma philosophy. It's about moving from asking, are we good enough, to knowing exactly how good we are and how we can get better. And here it is. If you only remember one number from our entire conversation today, make it this one, 1.33. This is the magic number. It's the widely accepted minimum standard for what's considered a capable process. Hitting a CPK of 1.33 means your process is pretty darned good. It's equivalent to a 4 sigma quality level. It means you've built in a nice safety buffer, a cushion, so that even with the normal, everyday shifts and drifts in a process, you're still consistently delivering what the customer wants. So let's wrap up with the key takeaways. First, capability gives you that universal yardstick to measure and compare any process. Second, always remember, CP is potential, CPK is reality. It's all about spread versus centering. Third, a CPK below 1 is a huge problem. Your process is fundamentally not capable. And finally, that 1.33 number, that should be your minimum target for a healthy, robust process. And that really leads us to the final thought. Hitting a CPK of 1.33 is a fantastic achievement. It means your process is stable, it's capable. But in the world of continuous improvement, that's not the finish line. A CPK of 1.67 or even 2.0 means lower costs, better quality, and a much more resilient operation. So the real question isn't just, are we capable? The real question is, how much better can we be?